Let's check our sound here. Check our systems. How's everything going? You guys should be able to see what's going on here. Yeah, there we go. Okay. Let's check on Ranger. How's Ranger doing? That dog. Oh, man. All right. Give people a minute or two to show up. We'll do a little bit of Linux today. We are, I mean, it feels like we're always starting over, but the thing is, for people that don't do this, really the most important thing I think is just getting your hands on systems and doing stuff. Doing labs, doing practice, getting the skills that are useful for doing this. So we will go through, and I kind of have it set up where we're doing our labs. We always do labs, right? That's the goal of Sundays, is get labs just punched out of the way, get as many hands-on commands as we can, right? But while we're doing that, we also can talk about systems administration and other stuff that's kind of going on. So that's where we're at. That's what I'm working on today. Let me fix this over here. There we go. All right. So there's Ranger. Let's pull up our labs here. And I'm going to pop us into our first lab, which is Linux systems checking. And I will pin it for anybody that wants to do it with me. I'll just do a 20-minute pin over on the Twitch side and then the YouTube side. Russian cyber check over on YouTube. Hey, how's it going? We do labs today, right? This is our Sunday workflow, is kind of just getting in the systems and doing the labs and understanding the things, right? On the right, we have notes that are available in our Discord. So there's a Discord that we have, and in the Discord, whenever I get done doing some project or doing something, I put stuff down here in the, this one should be in the, I think it's under presentations. And last night I posted up the Socratic Ansible questions. And then the other day I posted up these notes. So these notes are the exact same notes that I have up here in Discord if you want to go through. And if you just get into, Killer Coda, just get into Killer Coda like this and start answering these questions and typing these commands, you can get a lot of information into your head about kind of how these systems work, right? Like if you've never done any of this, you can at least get your hands on it a little bit. So you're over here on the left, going through the lab, just following the instructions. It says you're a new system administrator at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation on it. That's a very common thing, guys. I mean, CMDBs will have, CMDBs are your configuration management databases. They have all the configuration of your devices in your environment. And some organizations don't have a good handle on that. In fact, I would say most. So we want to figure out maybe how we're going to go do it, how we're going to document what's going on in those systems, because one of the worst things that can happen is you go spend a bunch of time figuring it out and then you never document it, and then now somebody else has to do it later. Ugandan Hand said, hi, I want to learn from you. SMTP and SMTP out lab for email flow. We'll do it one day. Yeah, I almost always work in air-gapped environments, so I do very little with SMTP itself, as far as other than sending up like postfix forwarding and that kind of stuff. And I never handle email on the Linux side. I've always let other teams handle that. You'll find more of my skills in the Linux side of things deal with the building out of the systems and making them all look the same and making them all behave the same way. So while I can definitely put together a lab for SMTP one day, it wouldn't be as good as, probably other stuff that's out there. Programming for gas now. Interesting. I don't know what gas is specifically, if that's an open source tool or if that's just a phrase, but hopefully that works out for you. Let's do this. What's the release and version of the system? Can I say cat etc splat release and see information about the system? And the reason I use this is because this works on like 95 to maybe like 98% of modern Linux systems, because you typically have an LSB release, an OS release, a RHEL release, a CentOS release, some type of release, dash release on your system. So I always just use this because then I can find out a lot of stuff about the system. And even if we just stopped right here and said, well, I've never been on this server before, I know nothing about command line except that this guy just made me push this button right here and run this command, because you could literally just push this and it'll run the command. If I knew nothing else about this, I could go, well, it's something called Ubuntu, and it's some version here. If I knew nothing else about it, I could at least go throw that into Google or DuckDuckGo, right? If I knew nothing else, I could at least know the operating system I'm sitting on, right? Who am I and host name, that'll take you so far. But this is the kind of thing, you know, I'm having a system problem. I'm trying to add a driver. I've connected in HBA, like a hardware bus adapter, and I've connected it to the motherboard, and it's not showing up. Well, these are the things that you're going to want to run over and take to the Googles, right? The Google or whatever you're doing, whatever tool you use for searching. So this is huge. This might seem like, oh, that's super easy. Yeah, but if somebody's never seen the system before, this is how we start. Now, if you've been hired as a Linux systems engineer or Linux systems administrator, you're probably familiar with some of these a little bit, but that's fine. Everybody's got to start somewhere. The next one that's hugely important is understanding the kernel that you're on. Your system, when it booted, it was called with a certain command line call from the Grand Unified Bootloader, grub, and grub2 in this case. And when it was called, it was given a location for your kernel. Where was the kernel for this system? And then that kernel governs everything else that happens in the system. In fact, from the time that this call happened, you've got this little thing, D message. I'm going to do DMESG, and then I'm just going to go like head-15, and we'll see the first 15 lines of D message. This is everything that happened in your system from the time that the kernel started to boot. Right? Hi, hey, Isobu, this is us just doing labs. Yeah, it's not a new lab. It's you'll find on Sundays we do a lot of kind of getting new people into this. Like, this is all lab Sunday, getting hands-on, practicing stuff. I think there's value because sometimes, you know, I learn stuff even when I go back through stuff. It keeps you sharp. Understanding how to query your system for information is very important for systems engineers and systems administrators. It is Sunday. I haven't had a day off. I haven't taken a day off in the last like 3 weeks. I've worked every single day, even the weekends. It's been wild. Runamucker, how's it going? Thanks for the gift sub to Isobu. Hopefully this stuff is useful to both of you guys. We're over here. We're looking at systems and we're just seeing what's there, right? See what's kind of there. Isobu, you might want to refresh your browser just so that you don't get any commercials anymore. Uptime, boom. Uptime shows us how long the server's been up. That's tremendously useful for troubleshooting. I tell you guys all the time, when I go to a server for the first time, if I get rebooted, if I get called out in the middle of the night and I go look at a server that I've never been on before, I always do these two commands. Last more, and then uptime. And the reason I do that is because the uptime will show me, has something changed on the system that's caused a full reset of everything. That's problems happen when servers are rebooted. If I don't see that, or if I do, it doesn't matter. I always do a last more because that'll show me who's the last people that have logged into the server. And I tell you guys, and you probably think like I'm being sarcastic about it, but I can't tell you how many times, it's literally over 20, that I've been called out in the middle of the night and the dev team is on and the bridge team is on and the bridge team called me out because they're the ones that have my phone number. And the dev team is sitting there wringing their hands nervously on the call going, none of us were on there. You know, we don't know why the server stopped working in prod. And I'm like, I see 7 logins from your team at 11 at night, 20 minutes before this was reported. I guarantee you guys were effing doing something on that server. All you got to do is tell us what it is so we can go back and fix it, right? This happens, guys. Like, this is systems world. So, you know, and I tell you guys all the time, the point isn't to be right, and the point is, I mean, you do want to be accurate as an engineer, but the point isn't to be like, ha ha ha, I'm the smartest guy in the company because I'm the Linux engineer, and ha ha ha, move, right? Like that kind of stuff. That's not what we're doing. The goal is to get fixing stuff. Oh, so here's what more does. And the reason I pipe more is this. In this system, it wasn't going to matter. But let's say we go to my system. Where's my home lab? Hold on. Let's pull up a home lab system to show how more works. If you just look here, this is my home lab system, right? I'm going to pipe in last, and it's going to dump so much information to the screen, right? So if we wanted to know how much information, we can pipe, which will catch what was going to come to standard out, all this stuff. You've got standard input here. Standard out was going to come to the screen. We're going to capture that output, and we're going to do a number line on it in this case. So we see there's 716 lines here, guys. That's a lot. So the more, what more does is more allows me to look at it. Watch, I'll do the word count -L so it's kind of, or the number line. We're going to catch that output of number line, or of a last. We're going to apply a number line to it. So now we have this preceding column over here on the left that tells us how many it is. And then we're going to pipe it through more. And what more is going to do is it's going to stop at each screen. At each full screen, it's going to stop and go, hey, buddy, do you want some more? And if I want more, I hit enter to go line by line. And I hit spacebar to go page by page. And I can basically spend my time looking through all of the content in the server. If I want to, I can hit Q to exit. I can go look again, and I can see, okay, the last people, the last logins of the system were all this streamer login. This might have been me logging in last night. This might have been other people logging in during the stream last night, right? So more catches the output and then allows us to have it kind of in a digestible format. It didn't really matter here, but I didn't know what was about to come out when I typed last over here. So more just catches the output that was coming to standard out, which is right here to the screen, and then it causes it to be in a more human readable, digestible, page by page format until you get all the way to the end, right? So I was going page by page there. So that's kind of how that works. All right, and then we did the cat-proc command line that showed us how the system was actually called by the Grand Unified Bootloader. So we've talked about the boot process of Linux systems before. You know, Linux system comes up. You've got the power on self-test of the actual physical machine. The system does whatever it's going to do, and eventually it goes and it scans the hard disks looking for a master boot record, finds a master boot record. It falls into there. Grub tells it, go ahead and start this kernel that's located here. Well, even before it starts the kernel, it starts the initramfs, right? Initramfs gives the basic instructions for pulling up the file system and very basic things that need to be there, and then the kernel can be called, right? And that's what this process does right here. And we've looked at that before in labs, and we've seen how that kind of works and all that kind of stuff. But before we think about any of that stuff as like a systems engineer, if I'm just a systems administrator and I'm just looking at these servers, I can go back and look at how this server booted. So the question might be, right, we might go here, look at that, and then look over here, and the question might be, let's clear both of these. If I told you nothing else about these servers and then I did this, I'm going to do that over here. Then on this system, I'm going to do that same thing. You guys have never seen this system before, right? Maybe you're new here. And then I'm going to do cat proc CMD line. And I'm not going to tell you guys anything else, but I'm going to ask you a question. Were these systems built the same way? Or another way to ask that is, are these the same system type? Would I go about troubleshooting problems between these two servers the same way? This is not some philosophical question. This is a hard, like hard nose to the ground engineering question. I just showed 3 commands on each side, and then I very simply go, are they the same? Like it's back to like that whole one of these things is not like the others. One of these things isn't the same. Like very much, you would very quickly look at this and go, holy hell, those are different servers. Jeez, man. There's no way. What are we even talking about here, Scott? That's what most of you should be saying. No, one's an Ubuntu server and one's a CentOS server. If I knew nothing else, those are different. But then you dig in and you see oh my god, one's a 5 kernel and one's a 3.10? Did you guys know there's still 2 kernels? There's still kernel version 2.6 in some of the older Red Hat servers that are still supported out there. We're all the way up on kernel version 6 for some systems. That is a huge swath of difference between if I'm doing like an ls mod, right? grep-i eth. Let's go net. And over here, I'm doing an ls mod. grep-i for net. If I knew nothing else about these systems, and I was trying to, you say, hey Scott, why isn't the inet diag on both of the servers? I'd be like, shit, I don't know, but they're completely different boxes. Yeah, inside sources, you're on 6.9. Yeah. I mean, think about this. There are still production versions of the kernel version 2 for Linux out there, and that's a real thing. Also, got some love from India over on YouTube. Yeah, I'm glad you guys can. I'm glad that people from all over can at least get into Linux systems. You do not need, I mean, you don't need me in general, but Killer Coda, if you just close down the window here and never watched or talked to anything from me again, I think Killer Coda is the best thing you could go pick up. You literally can spend 10 minutes a day from now probably until the end of your career, and you would not run out of content that's free on that site. From now till the end of your career, 20, 30 years from now. There's so much free stuff on this site that if you were spending like 10, 15 minutes a day just trying to learn about it, you would find more and more stuff. There's always more stuff out there. All right, so anyway, so I'm here, I'm looking at these systems, and it doesn't look like we're doing much because there's not that many commands flying around, but I am picking up all the different things that could kind of be happening. I can start querying again the internet for common problems around this version of the kernel here and maybe a certain driver that I have. I work very often with like NVIDIA and Mellanox. Mellanox got bought by NVIDIA, but Mellanox was a very fast, they built InfiniBand, right? And then now NVIDIA controls it. And NVIDIA is like, first off, they're very big from like making video cards and GPUs. You guys know that. But they also are like the kings of the high performance compute world as well. They are very, very big in that space. So we do a lot of stuff with their tools, but we use Red Hat or SLES, which is the SUSE Linux Enterprise Server. It's SUS. Anyways, it doesn't matter. Then we have to add or remove drivers sometimes for the cards and the hardware. And we get these big matrices of things that are supported and not supported. So like, let's go to like, I don't know, InfiniBand, Rel 9 matrix. Let's see if somebody's got, yeah, like the Mellanox OFED firmware driver compatibility index. And we'll go, this is the thing, guys, you think, oh, I want to be an engineer, oh, whatever. This is something that we have to go do. Right, so let's go, let's see if we can find support overview. Sometimes they have it as a table, sometimes they have it as you can just download it. Oh, they've moved, see, now they've moved over to NVIDIA, whatever. And sometimes you have to actually open a support ticket to look at this stuff. They might have it out here. They normally have this stuff open. Let's say we have an InfiniBand switch cluster. And then let's see if, oops. Are we using a fat tree or a dragonfly? There's all these different topologies of networking that we can use. And then are we using a HDR 200 or a NDR? I don't even know what NDR stands for. I know the speeds on them. And then I can go and look at this and it'll generate like a detailed configuration of my devices if I have them, right? This is not exactly what I wanted to show you guys. There's matrices that they keep out here. I don't have any of them on my. This is my non-work system, so I don't have any of them. But the point is, you can find them, and then you can go compare. Does this version of the kernel work with these modules that I want to load to install this certain type of firmware and HBA type adapter or whatever? What happened? ISOBU said I had a problem with our entire data center team missing a simple link down on a redundant port of router. Guy who received the ticket, though thought everything was good, even without even thinking. Yeah, ISOBU. Yeah. People sometimes. This is one of the reasons I actually enjoy working with junior engineers and interns and stuff, is because sometimes I'll be like looking at something and they'll just like point over my shoulder and be like, "Hey, what about this?" And I'll be like, "Oh my God, I didn't even think about that." This is one of the things I tell people, like, and this does sound kind of like I'm being philosophical, but it's like almost like looking at something with fresh eyes. Like, if you've ever looked at a system for years, like you're in a system and you've built this system and it's your baby and you know all the ways that it works and stuff, sometimes you do get blind to problems in that system that somebody else comes in and goes, well, that's weird. And then you're like, that is weird. How the hell did that happen? And then you go look at the script that deployed it and it's got your name on it and you're like, oh God, that was me that did that. Why did I do that? What was my thinking? And you'll never remember, guys. That's why I tell you, make sure you write notes. As an engineer, make sure you have a note-taking process. It's actually something I'm going to talk about in a couple weeks in our big Prolog 5-year anniversary type thing. Is I'm going to talk about, like, your note-taking process is very important. I have found that I am woefully underprepared in my note-taking process. My notes work really good for engineering. I've shown you guys what I do. I do stuff in systems. I pull out relevant stuff so that it's in my notes like this. And then when I'm ready, I take these notes, which are kind of raw, and I pull out what I want, and I make my good-looking documentation that becomes like the official documentation, or what I send off to the customer or different, whoever. And so as we kind of think about this and build this out, this process works really good for me as an engineer, but I was woefully underprepared for, like, my doctorate work. I have to read all the time, and I have to annotate work and citations, and have literally hundreds of citations annotated of different articles around my chosen source of what my dissertation is going to be on, which actually deals with the business side of cybersecurity, which is funny because the things that I'm doing in my dissertation are very similar to what just happened with CrowdStrike, and I think that's kind of funny. Hour later, the switch is dead. Yeah, ISOBU, which is funny because all they had to do was walk out there and look at the ports, and you guys with normal color vision, you immediately see it. I'm colorblind, so like I take a little longer to see it. Typically, I have to look for like blink patterns and stuff. Some of those greens and yellows are super close to me. Doc Mallet, rumor new drivers will not be open source, or will be open source, not old ones though. Yeah, Doc, I'm interested to see what NVIDIA does. They're winning so that, like, they're so far ahead of everybody on the NVIDIA side of things that, like, you guys ever see, I like to use examples that I think people know. Does anybody here remember the first Incredibles movie? It was this Pixar movie where they were superheroes, right? Doc Mallet, you usually almost always have several kernels to boot from, so you will know which ones you're booting off of. Sure. NVIDIA does have open, actually, like 3 of my colleagues over the last 5 years or so, have gone to NVIDIA. And I just actually got a recommendation. I was looking at LinkedIn earlier today, and there was a recommendation to go over to NVIDIA for some of their high performance compute stuff. Yeah, and I probably work with NVIDIA engineers 2-3 times a week. So there's quite a bit of work on that side of things for people. Yeah. But with Doc over here on the back to this thing. Anybody here remember that movie? Right? It's kind of silly movie. It's called The Incredibles, and they just did part 2 after, like, God, it was like 15 years, and they finally were like, oh, we'll make a second one. The search for more money, as Mel Brooks put it in Spaceballs 1. Well, because they're coming out with Spaceballs 2. But if you ever saw Spaceballs, there's a scene where they go, will we see you again, Yogurt? And he goes, you may see me again. It'll be in Spaceballs 2, The Search for More Money. Gotta love Mel Brooks. But hold on, where I'm going with this is in that movie Incredibles, right at the end, they finally let their kid Dash go out for sports. And Dash is running against the other kids and they're cheering him on, but they're like, yeah, no, slow down just a little bit. So the kids get like, he's beating all the kids in a race so much that like they're cheering for him to slow down, and all the other parents are kind of looking at him funny. And that's kind of how I feel like with NVIDIA. They're so far ahead of everybody that like, if they don't want to start having all kinds of, they don't want to have all kinds of investigations, they're going to have to like start slowing down and letting other people catch up. like NVIDIA is big time winning. They can't. They're yeah. I've been on like the back end of like people ordering more of their GPUs and stuff. Their stuff is back ordered for a year on some of their stuff. You can't even get it. You could throw all the money you have in their face and you're not going to get it, because they've literally moved everything around to get it to the people that already did stuff a bunch of money in their face. So their salespeople are just like sitting there waiting for calls, you know. They're not even outbound calling. But anyways, that's neither here nor there. We're doing the engineering side of things. We don't care about the business side of things right now. We're going to dig a little deeper into this system, and we're going to think about what we're looking at. We've got some device sitting here. We know how it's made. Let's look at some of the memory usage. So we use a command like vmstat. This command does not look super cool like this. Let's make this a little wider here. And I don't care so much as we look at this command vmstat. I don't care so much about what's going on in the system right now. But what I do care about is that I've got free memory, however much memory that is. I've got some in buffer and some in cache. And what vmstat allows me to do, it's part of the sysstat package, and it allows me to look at the system over time. I can look every 1 second forever, like this. I can do like we just showed, where I can say every 1 second for 5 iterations, and it'll look like this. Doc, I don't remember that, but that's one of the funniest things I think I've ever heard. He just would go beat it by 1 centimeter just to get a reward. That's and to have his name in the record books all those times too, right? That reminds me, there was this show that used to be on called Pros versus Joes, and it was on Spike in the early 2000s. And if you guys don't know what Spike was just like a guy's channel. It was all for like young guys, and I was in my early 20s, right? In the early 2000s, I had just got out of the Army, and Spike had this show where guys and girls that were pretty fit from a local gym would go up against former professional athletes, right? And to Doc's point, Doc said that there was a guy who would just go and beat his own pole jump record. So what they did in this show was they had these 3 people lined up, and they were going to have a 1 mile race against a former professional athlete. And the one guy, he goes out and it was how much they beat you by, not what your score was. So it was going to be like basically how much they gapped you was whether you won or lost. So the first person goes out and he runs like an 8-minute mile, that's a respectable mile. It's not a great mile. I mean, when I was in the Army, I was running like 5-minute miles for distance, right? And this is some guy, and he's out there running, and he runs like an 8-minute mile. And his Joe runs, so he's the Joe, and then the pro is a former basketball player, and that guy runs like a 7:30, right? So he beats him by 30 seconds. So then this girl goes out and she runs like a 7:30 mile. And then this former tennis player, female, goes out and runs like a 6:30. So she beat her by a minute. So she got beat by more, so the other guy was the one in the lead. And then this guy comes out, and the Joe is pretty fit, and he runs like a 6-minute mile. And they're like, all right, he's probably going to win it. And then this dude comes out, and he was a former soccer player. And they were like, hey, how's your, do you still run? Do you still play soccer? And he's like, I play a little bit of soccer. I do like a couple leagues a week or whatever. Former pro guy, right? And you think this dude that ran a 6-minute mile, who smoked the other 2 Joes, is going to win? That soccer player looked like he was jogging, and they showed his time, and it was under a 5-minute mile. He had like a 4:30 mile or something. He looked like he was He looked like he was on a fun run. And he smoked that guy because, like, what's the average soccer player run, like 8 miles in a game or something? Anyways, my point is, that's kind of like what Doc was talking about, the guy who would break his record by just a centimeter. That's actually pretty funny. Yeah, so this tool will show you things, and VMstat has some very specific values in here that matter. I'm going to pull up one of my other presentations that I have on administrative tasks, and we can look at how VMstat works. Over here on the R, by the way, let's say you're just looking at a Linux command. Let me back up a second. Let's say you're just looking at a Linux command in a box like this. How do you know what the hell any of this stuff means right here? Well, this is where we read the field manual, guys, right? We come in here, read the RTFM, read the field manual. I can man VMstat, and the system will tell me all of those values that are interesting to me. Here's the different, these are the options that I could throw to make it act different ways. And then down here is, what is it actually showing me? And these are useful. So the R is the number of runnable processes running or waiting for runtime. So if I come out here, there were no processes waiting for runtime on the kernel right here. That's actually a performance indicator. Look, we come over here. The number of processes running on a CPU, a value greater than the number of CPU count, is called saturation. When we deal with saturation, right, we've got this concept in engineering. I always show you guys this. This is the utilization, saturation, and errors of a system. And the way this works, if we go back up for a second, I just keep backing up. Hold on. Utilization, saturation, errors, the use method. This is the way that we look at systems, right? It's a way to think about tooling. Hold on, let me pull this up. Whoops, I didn't mean to do that. I meant to pull this up. Ignore. All right, let me pull this stuff back up real quick. Hold on. Here, and our notes. Okay. And then also this one last thing, which was the actual presentation we were on. So I'm going to change to my pen here real quick, and I'm going to draw the utilization of the system. If you look at a system, you have between 0 and 100% utilization of a system. So if you're just thinking about a system and how much usage it has, this is the utilization right here. So this is utilization. It is 0 to 100%. It is how much is the system being used. But then when we get to saturation, this is wait. This is wait time. So we've gotten to 100% utilization, and we start to go off this way with a queue. I think I even say it down here. How resource busy, what's the queue length, and we start to get a wait. And then over here, we get timeouts. And the timeouts are where errors start to go, hopefully into logs. So the system is always, we look at the utilization, the saturation, and the errors of the system. And that's a very, like, in a troubleshooting sense, in a systems engineering sense, it's very good to understand, hey, what is my utilization of a thing? How much of a thing am I using? Okay, I'm using a high percentage. Now there's a wait to get to that resource. That is my saturation. How saturated am I? Saturation that leads to long queue times and eventual timeouts is where errors start to occur. Errors get logged here. Errors get logged back in systems making API calls. Whatever. It doesn't matter where. This is a good model for how a system is being used. If you're trying to profile or find errors in a system, this is huge. And this is, again, I tell you guys all the time, this is another way to look at the system. If this way doesn't help, throw it out. But it is a way to look at systems for now. Okay, let me get this thing out of the way. Doc said, when you have some time, could you explain the difference between grub versus system deboot? I'm actually absolutely lost. Plus, I have catastrophic failure, and I'm booting from bootfix USB. I don't think so. Grub versus system deboot. I don't know if I've ever directly messed with system deboot. I don't know if that's a newer thing. Um, Doc, I will look into it, but I don't. I mean, I don't know for system deboot to occur. I would think that's after some kind of grub or other type of, because typically we've got the bootloader kick up, start the systems, and then system D starts after the kernel comes up. It's a function of the running process 0. In fact, system D is almost always 1, but system D actually doing the booting. That's interesting. Yeah, I haven't messed with that. So if Red Hat's trying to remove grub, that's interesting. I haven't played with that any. So I'm still using grub to boot stuff. Almost exclusively grub 2 if we care. Yeah, I'd have to look at how systems are booting there to see the difference. I don't. Interesting, Ewell. I'll have to look into that. Okay, so back over here. By the way, there's questions on the right. If you're like, oh, this is kind of going slow, Scott's talking a lot, you could always just be putting the commands in at the right and just dropping those in. And also for anybody, these commands are up in our Discord, so you can actually run through this whole process with the original visuals too. But then we got mpstat. What's mpstat doing? That's showing us how much usage we have against the CPUs, right? And mpstat also has all these different values that you can go read the man pages on. It's a port of popular bootloader called Gummy Boot. Despite the name, it's not actually related to System D whatsoever. Interesting. I've never heard of. Let's see this. Gummy Boot. Oh, System D boot over an Arch. Interesting. Gummy Boot, German for rubber dinghy, is easy to configure. UEFI boot manager. Supported file systems. System D package dependency of the metadata. Yep. Yeah, I have not played with this any. Still have to have a separate boot partition. Still has to be a master boot record, meaning that the system determines that it's bootable. Yeah, I mean, it looks interesting. Looks like there's some interesting stuff going on in there. Interesting. All right. Yeah, I'll have to play with it, Ewo. Play with it, EWO. Yeah, sorry. The thing is not getting my attempt at saying a name. So the closed captioning very rarely, especially if people come in with names like something that just doesn't make sense to the closed captioning, and then I try saying it, and then the closed captioning is just like, well, I guess I'll die. I guess I just won't tell anybody anything. And I'm like, thanks closed captioning. I'm glad you made it sound like the one time. What did I say? Something about like wrestling around with men, like with jujitsu, and it just said, well, that sounds pretty bad in itself, doesn't it? But anyways, this thing made it sound really awkward, and it got turned into it got turned into a clip, so that my Discord could be amused. Yeah, we'll leave that open. We'll play with that later. I can come in. I can look at. Let me show you guys something about a system, and I show you guys this. We ps-ef. It'll dump everything to the screen, and I could do like I did earlier, and I could put a number line on it, or I could put a word count -l and go, okay, there's 121 lines coming out of this command. I don't know what they all are, but maybe I want to figure out like, well, so. Let's just say like head. So we clear the screen, we do a ps-ef head that'll show us the first 10 lines of something. So it's the, if we have some kind of legend at the top and then 9 rows to let us see. And I go, okay. I wanna filter this down. And there's an example of it over here. But I want to show you guys, you can use a tool called awk. Awk is its own programming language. I've seen some people, in fact, there's some stuff over here where people really dug in and know awk well. I basically use awk as a column filter. That's basically what I do as a systems engineer. And I want to see, just show me the first column all the way down the line. I just want that first column. And when I do this, it'll strip all that other data and it'll just give me that first column. And I go, well, that's cool. But now I kind of want to like order it and enumerate it. So I'm going to sort it, and then I'm going to say unique and count it as you make it unique. Now I can look at this system and go, okay, there were 121 things going on. The header doesn't count, so there's 120 of them. Well, 116 of them are just root, probably system stuff. Messages, daemon, syslog, and systemd, those are not actually users. So if somebody were to say, hey Scott, is this system actually doing anything, or is it just sitting there mostly idle? I'd say system's idle. And these other commands can help me determine that too, like this mp stat. Mp stat can also show me this box is sitting. If I knew nothing else about it, I can determine that this box is pretty much idle. Look at that, it's all idle right here. Can literally make an awk shell file like you would the shell file. Yeah. You can. Awk is a full programming language. Awk, look, I don't mean to disrespect awk for anybody, but I've seen some effing cool stuff come out of awk, even in one-liners. But I've seen people program AWK, and it's pretty good. It's awk. AWK. Capital A, capital W, capital K. Ah, damn. Hey, non-major nerd, how's it going? Yeah, Doc, it sounds like there's definitely people in Discord that know that better than me. I haven't played with that, but it sounds like Ewo's played with it a lot more and probably uses it or supports it. So I tell you guys, like, I definitely don't know everything about the systems world. I've just been in it a long time. I tend to work with whatever's working, so you guys will find that a lot of my stuff, it kind of even probably looks dated, but the thing about it is it works well. That's, typically my stuff is well vetted. I'm not on the early adoption curve in a lot of my projects. I try to do stuff that's pretty newer. I do a fair amount of Kubernetes myself and that kind of stuff, but not professionally. A lot of my professional stuff ends up being just keep the system running. It's a fast system. Let's keep it drag racing down the line. And keep the rate. If you got a drag racer that goes 310 in the quarter, you're probably on a rocket. But my point is, you're not going to spend a lot of time trying to tweak that. I mean, you tweak it to get to like 315, but you're not. And that's quarter mile for you guys that don't or haven't done drag racing. But and that's 315 miles an hour, not 315 like a time, or a fraction. I don't know if you guys are seeing that closed captioning. Every time I look down there, it distracts me because it is never doing what I want it to do. I look down there at that closed captioning and I'm like, good God, this thing is terrible. Sometimes it's all right. It's doing all right now. All right, another one is iostat-xz, and this will show you every second for 5 seconds what's going on. And then I have questions, right? Like, I'm always asking you questions when you do labs because, again, you can just come in here and put your head down and just press these buttons as fast as you want, but you might not learn anything. So you got to like pick up your head and think about what's going on in these systems you use. And you might think, well, that's that sounds like something for like a sysadmin or an engineer to do. And I go, well, yeah, that's what we want to do, isn't it? Most of us want to get into systems engineering. Some of us want to get better at doing some of this stuff. So that's the goal, right? Is to get you guys understanding this stuff and getting better at it. All right, so I'm going to, let's see right here. We're at 45 minutes. We're still doing our first lab. Let's look at Ranger Dog. We'll go give Ranger a treat. Let's take a break real quick. We'll say hourglass. Take a quick break. Let's say quick break, and Ranger treat. We'll go 8 minutes, and I'll unpin that first message. We'll come back over here. Yeah, there's a Ranger check. There you go, Run Amucker. There's Ranger. I'm gonna go give him a treat on stream here real quick. I'll be right back, guys. Alright, how's Ranger doing? Good old Ranger. Guys, I didn't even think about this, but I could turn my camera on today. It is a little bit cooler in here. Get this thing set up here. One second. Think about turning my camera on today. I was too busy messing around with other stuff. Hold on. All right. Oops. I want to break my damn chair. All right. Let's see. Oh, mother effer. Knocked everything down, guys. Alright, give me a second here. Try not to break everything. Everything was here in the exact right spot. And then I moved this big beanbag chair in here so the wife could hang out by me. And then now everything's all busted. Alright, hold on. That's okay. We're still on break anyways. All right. Move that in. See what the camera looks like. It looks okay. All right. I didn't even think about doing this. Hey, Robodom, how's it going? We are an hour in, messing around, doing labs, right? We do labs on Sundays. And some of the labs we do might look pretty simple to people, but this is like bread and butter stuff. This is like stuff we do as engineers. And Ranger's down there eating his treat because I just gave him a treat. All right, let's hold on. Hold this up. We did all that. We did all that. We looked at the disk usage. We can look at a little bit more into networking, right? So I'll wait until the break's over, but I'm off for work today, so you can hang out. Nice, Robodom. Yeah, I'll be on a little bit longer. I've got a lot of work to do for actual work stuff. I've got some clusters to keep doing some security stuff for and get some logs. Not logs, but I've got a kind of like a matrix of compute nodes. I mean, in fact, I can show you my home lab. The reason I built my home lab is so I could show you guys something similar to what I'm doing at work, but without breaking any rules of, yeah, like good decorum. Don't be showing other people's shit out to the world, right? But in my home lab, I have over here, those are all red now, but I can go to profile. And I have just this default profile. And then I think images list. Image, maybe it's image list. Container. I'm still getting used to the commands. And here's my containers in my home lab environment. And you'll notice that I have like a Rocky 8 because I was testing. I have a Rocky 9. That's the one that we're using. And then I've got this Rocky 9 lab. Well, in this environment that I'm at for work, I'm doing like a compute image. I'm doing a landing zone image. So that's systems that people come in on. I'm doing management images, and I'm doing GPU images. So those are like my 4 major images. And what I'm doing is the images are built or they're getting built by other people, and then I'm stigging them. So I'm doing a stig process to get them to the government standard of at least like 90% across the board and working in whatever fashion we want. Do we want FIPS? Do we want SE Linux on them? Those kind of things. And I've got this whole matrix that I've built out of where the nodes are and that kind of stuff. So I am eventually going to stig these nodes in the home lab environment for you guys. Also, Robodom, I don't know if you were here yesterday. I got the lab set up where anybody can jump into all of the different nodes now. So anybody from Discord can hop in and they can jump into any of the nodes and they can do labs and stuff in there and whatever. There's like all kinds of stuff in there. So, all right. So we did that first lab. The lab just keeps walking you through and answering questions and that kind of stuff. And then you come over here and you just... The goal of this is to not just go through it and say, can you list the number of CPUs and then do these commands? Can you tell me the speed in megahertz? The goal is also to understand how these things work and why you would care. Like, why might you want to know the speed in megahertz? I mean, we can do a thing. We can see how the CPU operates in the system. We can see all these things. That's like administrator level tasks. An administrator can go. We can train anybody. You go on the internet and figure out how to do any of those things, but the engineer knows why they're doing the thing. They know why they need to report the speed in megahertz of the system, and they know why they need to know that all the chips are exactly the same from the manufacturer, so that doesn't affect downstream processing across a cluster. Like, these are the kind of things that are like an aggregate. I don't want to say like an aggregate knowledge. It's just a lot of the stuff you guys see me do is very simple stuff. Again, anybody can go on the internet and look for any of those commands. But I always tell you guys, like, any administrator can do a thing and make $60K a year. But the person who's really valuable to the organization, the person who's pushing 200, 300K a year, they know why they're doing those things. I do the same exact commands that admins do all the time. I do all these commands right here. But the thing is that I'm aggregating those up into reports, and I'm building things, and I'm reporting out, and that's like they're the same things, but they're engineering. So I don't know how else to put that except um, keep doing the basics, and eventually, as you understand more and more why, it'll make more sense to you, and you'll be more valuable, like, to yourself, and you'll also be more valuable to organizations as well. So, all right, something to think about. Let's keep going. You know what, we've done a lot of these, but we're just gonna keep plowing through the labs. So here's the next lab, super bright, but I'm gonna pin this lab for you guys over on the YouTube side. Pin that message, and I'll pin it for you guys on the Twitch side if you want to do it with me. I'll give you guys a minute or so to get in there, and then we'll start doing this next part, which is dealing with kernels and packages and seeing what is and isn't there on your system. I'll make that a little bigger so you guys can see it, and then we'll go from there. Other than that, what else we got? The next 3 days, I'm super swamped with work. I have to drive out to Chandler, which is about 45 to 50 minutes from here, depending on traffic. And then I got to go do work in a skiff, so I'm completely offline. I can't even have my cell phone in there. And my laptop, which I'm allowed still to bring in, is completely off of the network in any way. So I have to do all my work in there. If I need to, I can come out and pick stuff up and then bring it back in, like if I need like a document or something like that. But we are working on a big cluster with a tool called Bright, which Bright is actually owned by NVIDIA as well. So NVIDIA Bright cluster. And if you want to know about that, there are here's what it does. There's some pretty good stuff going on in there. I do everything command line, right? So all my stuff is all command line. My task this next week in that environment is we've got 2 nodes. They are not in highly available configuration right now. I'm going to take the primary node, and I'm going to configure the secondary node as a highly available alternative to it. So then they'll both be updated with the cluster tooling for being, basically they're the exact same thing. I'm going to set them to have the same back-end storage. We still got to set up the storage piece. That's part of why I'm going out there, is I'm helping the storage piece to get set up through this Sky Bridge or whatever networking tool they have. I don't even know. That's an NVIDIA tool too. And then those 2 devices, I've got a STIG compliance. I got to set them up to a certain standard of STIG. Again, trying to get around 90% compliance on those systems. And they're running, that cluster I'll be on is a Rocky 8.8 cluster, whereas these clusters are all Rocky 9.3. So like the stuff that you see me build, and then the stuff that I'm working on outside of there are like Rocky 9.3 clusters. So you gotta be able to like jump between these things. Oh, but anyways, if you come in here, if you look at the Bright Cluster Manager, how's it being used for data science? It works with all these different tools that are big on data science and like AI, and then there's a bunch of white paper stuff. So I'll link this to you guys. It's up to you if you want to go spend some time with that. I'll just tell you that's another tool that's out there, and that's one of the things that I've been building clusters on this now for a while. I've traditionally always built clusters on a tool called XCat, and then I'm getting more into Werewolf and Bright. Tomorrow, I never made an actual video for doing the STIGs. I did do a couple live sessions where we were doing them. No, I do actually have you guys have seen my notes here, and my notes are always just random. I do have my notes for putting together a STIG. Can't show you some of those. I do have my notes for doing that in an Ubuntu system. One of the problems that I have is the way that STIGs work in Ubuntu are completely different than they work in Red Hat and Rocky. You say, what do you mean by that? What I mean is there are Ubuntu 20 and 22. 24 doesn't seem to have this problem. No, sorry, 18 and 20. 22 and 24 don't seem to have this problem. They do not have the same STIGs as the other ones do. So I just had problems getting the STIGs to work on, because this environment that we're in is 20, right? Yeah, 20. I was having problems making this look like what I'm used to on the Red Hat side of things, so I kind of backed off of it a little bit. So yeah, tomorrow I haven't actually done that officially yet, but one of these days I'll get around to it. Just haven't done it. And yeah, sorry guys, I should have been on camera. I just didn't move my green screen, and then we'll get this going. So all right, let's look at our lab. You are a new system administrator at a company. You've been tasked with finding out information about a set of servers that has very little to no documentation with it. That's very common, guys. This is like your life, and people are gonna leave and just hand you over servers, and you're like, what the hell is this? You're gonna be like that guy going, ooh brother, what is that? You know, what the hell is this? Check kernel package info on the system, echo the number of kernel versions, and then find the versions of some specific software, right? So in our solutions over here, we have uname-a will tell us all the information about the kernel. And that's good, right? That's pretty good, because it'll show us all kind. We're on a Linux box, we knew that. Ubuntu. I tell you guys sometimes there's funny things when you do this. People will you'll see that it was compiled Ubuntu, and then like some message, and then the architecture of the chip, right? It's an x86 64 as opposed to just x86, which would be 32-bit. We don't really deal with that much. Or ARM. It could be ARM 64, which is most of your Arch type chipset, which is there's some really high speed computing done on that kind of stuff, and it's super low power. So there's different types of architectures for chips and stuff that are out there. But there's all this information here, and I know I have it. If we come over here and we look, I have this old version of Kali, and the reason I've kept the Kali 2019-3 ISO is if we boot to this, we could do this someday on stream. I'm pretty sure if we boot to this and then we do our uname-a, they actually put it in here compiled on Windows, or compiled by Microsoft is what it says. So there's a version of Kali, I'm pretty sure I have it. It's when they compiled the kernel, because Microsoft was so involved with it that they put their little title on it, compiled by Microsoft. And I'm like, you sons of bitches. I'm surprised more people didn't get up in arms about that. Anyway, so we got some information. We can look at the kernels that are on the system. Here's the versions of the kernel. Let me show you guys something. If we ls boot like this, but then we do that same ls with a -l, it'll show us a long listing, and we can explicitly say S, which will show us any symbolic links. But what happens here is now we get this totally different output. And this totally different output shows us that, well, there's really only one kernel here, and then there's a link to the kernel with no identifier as far as the semantic version. And then there's an old vmlinux.old, but that points to the same thing too. So there's actually only one kernel on this box. The other kernels don't actually exist. So from a computer science, from a systems engineer standpoint, I need to know that I can get a system back up and running after patching, and only having one version of a kernel is a big no-no. You want to, as you install a new kernel and then move to that new kernel like a little hermit crab, as you reboot the box, you must keep old versions of the kernel, because old versions of the kernel we know will boot. So if something goes wrong on this system and I get a crash when I reboot it, I step back, I point grub back to the old version of the kernel. I might have to do that in rescue mode. Yeah, 2 to 3 kernels. But Isobu, I think you've been around, or if you haven't been around, allow me to explain. The reason I got a CISSP, the reason I got that was because I was arguing so much with my security team that I wanted to have, again, if you guys want to know how petty I am, I spent $795 of my own money. I didn't get my company to pay for it. And I spent all that time studying to get my CISSP, just so when I was arguing with my security team, I could put Scott Champagne CISSP on my email. It's the only time it's ever been in my email signature, was when I was responding to my security team as I was arguing with them about this exact point right here. What we were arguing about was this. Their scanners, in all their wisdom, a Qualys scanner does this, Nessus scanner from Tenable Security does this. They go and they scan your Linux boxes as a privileged user. You give them the ability to sudo up and check things, and they go look at the kernel, and this is exactly what they do. They say, that's a Linux 5.4.0-131 generic kernel that has been identified in these CVE exposures. It's got a 9-level exposure for CVE, right? It's a common vulnerability and exploit. You need to get it off the system. And then you tell them, well, hold on. Pretend for a second. In this system, that is my default. I do need to fix it. But pretend for a second that that was my old kernel. That's just the kernel in the trunk in case this system crashes hard. And then they say, well, but you need to get that old one off. And I go, yeah, it's not executing. It's not being used. And they're like, yeah, but it could be used. And I'm like, it could be used in a recovery effort. And in the recovery effort, we would not be on the network and we would not be doing anything. We would just be bringing the system up, repairing it, and going to a new kernel. And they're like, you can't have it. And you're like, guys, listen. You're trying to explain to them that in an operational sense, I must have a spare tire in this car. And they're like, yeah, but the spare tire, think about it. A spare tire is dangerous. What if you stop too hard and it comes through the back and it kills you? And you're like, dude, that's a very low chance of that happening. 1, 2, but I still need a spare tire to operate this car cross country or whatever, right? And in prod, in the prod sense, prod is always up. So we need to have it. So anyways, we used to argue about that exact point. That exact point right there is how many kernels back can you keep? And can you keep a kernel? Can you, like, ethically and, can you, in good conscience, keep a kernel that has vulnerabilities on it for the sake of keeping your systems operational? And those of us on the systems engineering side, and, those of us that went and got our CISSP to argue it, believe that. and then other people don't. I used to get in arguments with this. I'm like, guys, you can't just take the findings and dump them out and say that we're vulnerable there. We're not vulnerable there. And they're like, why do you need? They acted like we were keeping it, like because we just wanted to keep something with a vulnerability. And we're like, no, we're keeping it so we have an effing spare in case something happens. Yeah, this was our GRC team. I used to argue, and then it's funny. I went over and I was in charge of it. So I was in charge of the team. And then I would be reporting up to the CISO, because I did that for a while, like red team over at AAA, and I was reporting to the CISO, and they're like, why do you now keep saying that this is an exception when other teams did it before you? And I'm like, because I know why. I know why the Linux team needs that extra kernel. And like somebody, as somebody pointed out, 2 kernels, 3 kernels. I always just kept 2 because I know the last one was good since my last patching. Can you put some notes right next to the name stating only for recovery purposes or no network use? No, too big. You can't, not really, not here. Like, because this is, it has to be bootable. So if you were changing the name, then the old grub, I guess you could do whatever you want with a name, but I wouldn't necessarily do that, especially across all the systems. But I see what you're saying. No, I would just put in the exceptions, and then they would literally every time go, that's a high finding. This is an easy one for us to knock out. And we'd be like, no, this is literally not an easy one to knock out because we need it operationally. And we butted heads about that I was the lead over there from 2016 to, ostensibly last year, 2023. Although I left for a little bit in the middle there to do some high performance compute with Redline. And then I went back to, so I was at AAA, I left, I went to Redline, I went back to AAA and I ran their stuff again and then became the red team lead, and then I'm back over at Redline. So like I've been jumping between the same 2 companies for the last 8 years, but I like working for both of them. It's just this, I do a lot more high speed stuff with Redline because I do a lot more high performance compute, and I gotta put my fan directly on me. It's kind of warm in Phoenix right now. Let's see, what's it at right now? We're at 10 a.m. It says it is already 100 at 10 a.m. So that's wonderful. All right. So we're just gonna say there's only one kernel. We're gonna echo that into a file called root kernel. We need that so the lab will let us go forward. I set this lab up to not allow you to move forward without adding those values. So we've got that, and then we go and we look at dpackage. Dpackage works with apt on Ubuntu and Debian style systems to install and remove packages and to show all the packages that are there. And in this case, I set a dpackage-l, which will list all packages. And then I piped that through a word count-l to say, well, there's about 726 packages. The first 5 are actually just headers, so it's actually about 720 packages, let's say. But I can search this. I can say, well, we are, security's been hounding me about our version of OpenSSL. Like, we know that just a couple weeks ago, maybe 3 weeks ago, there was a vulnerability in Linux, right? So we go look at, whoops, you want to grep it. So grep is your search tool. Grep OpenSSL, and look, here's all these things that have OpenSSL in some way used, either in the name itself, Python 3 OpenSSL, or in the description that's given as part of the package manager. So if somebody were to ask me, hey, are you guys using OpenSSL? And if you are, do you know what version of SSL you're running? I would be able to say we're definitely using OpenSSL. And right here, here's the actual package of it, and here's some information about the package. Now with dpackage, I should be able to get more detail, so I can man dpkg because I don't know how to do it, and maybe look for detail. I did a / to search, and then I'm just hitting N to look through all of them. Nope. So there's some query actions here, and I can print details about a package name. So I can say dpackage-p for OpenSSL. And again, I don't use these tools that much. In fact, I'm mostly all Red Hat professionally, but I just found right there how to find details. And this will tell me, so my security team may say, well, hey, when's the last time you patched that, your OpenSSL? I go, well, it was installed on, typically, this will tell us when it was installed. I don't see that info right here. I may be able to go find that from the logs. However, likely it's not in the logs. Things I notice about dpackage. I can immediately tell you that the Red Hat one's better in my mind because it tells me exactly when some. Look at this real quick. Let's see on the Red Hat side. So my Red Hat system, even Werewolf here, I'll say rpm-qa grep for OpenSSL, and I see OpenSSL is there. Oh, hold on. Yeah, there's my OpenSSL. So now I do an rpm-qi for OpenSSL, and we look at, this tells me exactly when it was installed. I'm actually very surprised that I don't see that here. We've got all kinds of cool information, but they didn't tell me when it was installed on my system. So I'm learning more stuff about dpackage. There's probably a way to find that. And whoops, and if I wanted to know how to find that, I would go back in the man page. And then I'd read the man page, I'd say / install. And then that says install, not installed, half installed. I don't care about any of that stuff. Can I see deinstall if I want to get rid of something? There's the -i is if we want to install. I'm looking for down in P where it prints, right? We can verify the integrity of the package, but we already did that. And there's audit. We don't want that. Get old, we don't want that. Yet to unpack, we don't want that. Don't want that. -L will list files. Let's try the -s over here for the status. Maybe the status will give us some info. Same thing, gives us some information about. Still not telling us when it was installed, so that's kind of strange. Could you kexec it? Kexec. I don't know. Oh yeah, Doc. If I'm trying to remove or add something, I pretty much put a dash Y automatically. Like, um, I deal with the fallout if I mess it up later. No, but I hate when I get asked something interactively on the command line for the most part. Maybe when I'm first installing something, but like if I'm writing a script or I'm doing something, I don't want it asking me questions. I just want it to do things. This is really bugging me. I didn't know that dpackage wasn't just gonna tell me the fucking date. Like, tell me when the thing was installed. Jeez. Anyways, all right. Well, we're gonna give the win to RPM on that one because the install date of something is probably one of the most important things. And you say, well, why does that matter? Well, because what if I had 30 machines and 3 of them were just behaving poorly, and then I go to look at it and I can't figure out what's wrong, but then it goes away and nobody's telling me that some other admin was asked or some other person was whatever, but I go look at something like this, I'm still digging in, and I find out that those 3 servers got fixed and there's this install date of OpenSSL to a new version or something. And I can do all this, all scripted and just run. You guys see me run the scripts over everything to just get the install date, and I'll see that those 3 are not like the other ones, and I'll go, how the hell did somebody, and I'll ask my team, did somebody install this? And then somebody will be like, oh yeah, I just fixed it for him real quick. And I'm like, yeah, but that was part of the problem. The other problem was how did they get in that state? But then also, like, somebody needs to know, because like one of the worst things is that question of this doesn't work, why? This does work, why? Those are both terrible questions. So dpackage wrapped seems worse. Yeah, I didn't know the dpackage didn't show you the date. That's mind boggling. Or if you ask him in what was that, Blades of Fury? Oh, it was called a movie called Blades of Fury. Mind bottling. Yeah, when your thoughts are all bottled up. The expression is mind boggling because it boggles the mind. All right, look at you learning Linux. You did these things. You did all these commands. Over here, there's a bunch of questions that, I just ask and you could go and look at. I don't think we get into any demessage stuff right here, but we do kind of later down. All right. So we're back over here. We're doing labs today. We do labs on Sunday. That's pretty much all we do. But we're also doing like some systems administration stuff kind of as we go, right? If we look back in my little presentation here, this presentation is Linux Systems Administration. It's about a lot of these things, and we were looking at some of these tools and how they work. I've went over this before. This is also up in the Discord. We talked about observability tools for like the big 4. Here's a bunch of things that like you just want to run on a system and see what kind of output you get. What kind of information is the system going to give you. Yeah, Tyre, the problem with var log dpackage log, which is that's actually a good place to go, except on these systems it wipes because it's probably been, I'll show you, it's probably been installed so long ago that it's not there anymore. So if I were to, okay, that's a good place to start, but it's not there on all systems. So, well, it is there, but var log in here, dpackage.log. So maybe I'll grep for open SSL from dpkg log, and I don't see it. It was installed before this log rolled. And you might say, well, when did this log roll? Well, I can go find how often this log rolls or log rotates in etc log rotate. And in here, I might find that dpackage is rotated monthly, and then it's compressed down and removed. But you got to remember, this is an image, so it was deleted off of this image, or there was nothing on it in this version of the image. So if I do just I don't know, word count -l on dpkg.log, this, oh, there are some things in there, but that thing was not installed in part of this. So we can just cat that file if we wanted to, and we can see what's there, but that will only tell you if something is there that hasn't been removed. zgrep I don't ever use zgrep. See if things have been removed or. Yeah, I wonder, but not if it's not there, right? If we'll do it. We'll do it. Install, remove from dpkg log, and then I guess from here we'll grab. But that tool's not there, right? OpenSSL has rolled out of the back of the log, is my point. So that's another one of these that. By the way, that also highlights what I'm always telling you guys. You got to get your logs off your servers. Your servers are going to do ratchet, stupid shit. They are going to be rebooted. They're going to be effed with. People are going to delete things on accident. They're going to fill up memory. They're going to fill up disk space. They're going to do all kinds of all the dumb stuff you never thought was possible. I mean, just think about it. Leave some cool looking thing out where kids can play with it in a sandbox. They're going to mess with it. Your users are more destructive than kids are. Your users are going to break literally everything they can get their hands on. So you got to get stuff off the systems. So yeah, RPM's just better for sure. It's tire. It's not there. I mean, I can add an L to that, but it's not there. My point is it's rolled off the back of the log. So, but yeah, it's not. Here. Just so everybody thinks I'm not trying to hide anything. OpenSSL dpkg.log. Not in there. So again, logs are great, but logs on a system, people can do bad shit to them. This system itself is part of it's cloned every time it stands up in their environment. So it's whatever the state is of that system. And you will find that sometimes I've actually been in these systems where there's nothing in dpackage.log. You don't even know when the last time things were updated. App log will be wiped sometimes too. Here, you won't always see what's going on in here. So the way they build their environment, something cleans some of this stuff out. Yeah, too big. I always tell you to send stuff to an external location all the time. Yeah, we have a lab on that actually. So we're done with that lab. Go back over here. If you want that lab, just go down to the bottom. It's like the second to last one. It's called setting up our syslog to capture and send logs. That's one. And then the other way that we get all the logs off the system is right here with Loki and Promtail. So Promtail will forward logs off to Loki. We love Loki. Loki is part of your Grafana monitoring. It's a great tool. I think it's a good thing to do. Rory Bellows, hopefully this stuff's useful to you. Thanks for the follow. Also, Robodom is linking Discord and all that stuff. I think he's posting. Those are the labs that you guys can look at. We'll keep working. We'll keep working on this. What's our time at? Oh, we're only about an hour 30. Okay. Let's keep working on labs. We'll do the disk and mount point stuff because this is very important. Understand how disks work and I'll unpin the old message and I'm going to pin the new one over here on the YouTube side, and then I'll pin this over here on the Twitch side and pin that. So here's a lab. This lab deals with the disks, right? You have different size disks. This is actually one of the limitations to Killer Coda. I think Killer Coda is a great site. I don't have anything bad to say about it from like a learning and knowledge standpoint. The only limitation here is that they won't provide us with disks for you to carve these disks up. If you say, hey Scott, I really want to follow along and do this with you, this is how you could do some of this lab stuff. If you come over here to our Discord, in our sandbox, I have how you can access the Prolog environment right here. This shows how you can connect to the systems that I have here. And if any of you are like, hey, I got in there and I got to one of the, so there's these 5 Rocky boxes. And if you want to see me carve this stuff up in Rocky, I'll show you how to do it with PVS or with LVM, which is Logical Volume Management. I'll show you guys that. But we'll do that after this lab. So again, you're a new systems administrator at a company. You've been tasked with finding out information about servers that have very little to no documentation on it. That's a thing. You need to check your physical disk information, echo the total number of disks that you have into root disks, and then echo the number of partitions that you have into root partitions. So that's what we're doing in this part of the lab here. I'm going to give you guys a second to come back from, looks like people need to come back from ads over on the Twitch side, so I'll give you guys a few more seconds and then we'll go here. Some people don't get caught with ads, some people do, so I'll give you guys the 15 seconds or whatever. Let's go check on Ranger Dog. How's Ranger doing? That dog. All right. We'll get rid of the bright cluster because we don't need it right now. We'll leave the system boot stuff up so I can read it later. And one of the things you can do is look at all the disks that are in this environment. So fdisk is one way to do it. You also have parted. There's other tools that you can go get better at if you want. I've used fdisk for ever. So this is a way to do it. If you just do fdisk L by itself, well, this is a valuable thing. It's going to dump a lot to the screen. And it's going to show you disk information by reading the blocks out of /dev in the environment. So look, it looks at dev, it found this loop 1, loop 2, and loop 3. Those are, as far as the system concerned, those are block devices, but they're actually memory locations. So we're not worried about those loop 4, loop 5. But the one disk, see, it thinks they're disks, but those are actually just memory locations. Dev VDA is right here, and then here's the carved down partitions of that device, right? And Suriana Quest, hopefully this stuff's useful to you. Thanks for the follow. LS block. We're going to do LS block in a second. Any scripts to check the certain mount points, and if they aren't mounted, to get mounted itself, asking for a friend. Yeah, Doc, the best thing about, I'll show you what I do with mounts. But let's keep going on this, and then we'll get there. And then I said, why did we use VD? Why did we look for VD as opposed to SD, which is typically your SATA disks, right, that are connected? Why did we use VD? Well, because it's virtual disks out here. And in my home lab, we would use XVD typically, because XVD is how Zen does it. And I've told you guys this before, when you go in and look at, I'm not going to go and open up my cloud right now, but if I go into my AWS and I spin up a box, and then I just set a basic AMI image with like Amazon Linux, you know, well, Amazon's up to Amazon Linux 3 now, but it would do Amazon Linux 3 and put it on that box. The virtual disks are still XVD underneath the hood, because that hails back to the old Zen partitioning, and I just think that's kind of interesting. So, all right, so we checked all that. We do LS block here. LS block is going to show us those same devices that are not really devices, they're just memory locations. And then we got a VDA, and then it's carved down into 3 partitions. We can do block ID. I love block ID. It shows me more information about kind of what's there. And then I'm going to answer the question, which is I have one disk. That's this guy right here, VDA. And he's got 3 partitions to that disk, or he's been carved up into 3 partitions. So the question earlier was, is there a way to check what's supposed to be mounted, which is in etcfs tab, with what is mounted, M tab? And so look at all these things that have been mounted on this box. There are a lot of them. These are the things that are supposed to be there according to the etcfs tab. In modern Linux systems, we're not always using fs tab anymore. Sometimes we're also using a tool, we actually use system demounts as well, right? What does echo into root mean? What this? This is simply generating files. I made 2 files. So I'm in temp, echo Scott is so great into some file, right? Cat some file, it threw that data in there. We did that same thing with this. So echo 1 just threw the number 1 in there, and echo 3 just threw the number 3 in there. That's all it does. This wasn't like I wasn't being sneaky. And then if I wanted to have a bunch of those, I would keep appending to that file, right? And if I wanted to only have one of those again, I would clobber the file, and it would be down to only the one entry. So that's a redirection thing that's important to know. Like literally every Linux test out there is going to ask you something like that if it's a question-based test, because you need to understand the difference between appending to a file and overwriting a file with redirects, and that's what those mean there. Yeah, tomorrow I don't use the systemd side of things much, but basically you can have systemd mounts. Let's see if Rocky has a good thing on them. Let's see if we can see, is there a good systemd mounts? I like the way that the Rocky documentation shows a lot of this stuff. Yeah, that's not a good one. Let's see if they have anything up here. So this is where I would tell you to go probably tomorrow, because this looks like it has some of the mount information. Hold on. How it comes up, and then where it calls the actual mounting. Yeah, they can have cascaded mounted file systems. That's true. Let's see if we can actually see where they do it. So it does local file system, and then they'll start calling them. So a lot of times what we'll do is we'll just go and we'll define a mount in there. Let's see if they have an example of a defined mount. I don't use this anywhere outside. Actually, I've only used this like twice ever professionally. It calls the mount, does all that stuff. Systemd.mount. So we can go read that. Come on. If it's there. And typically you'll just go make a directive, or whatever, I guess a mount directive, if you want to think of it like that, and it will mount it as the system comes up. They give you all these things. Let's see if they have one. I actually don't know. CD etc system. They may. Oh, yeah, here's the mounts. So these different things that we're mounting, we can go look at one of these mounts. So this is how this is mounted on the system as it comes up. And then I should be able to grep like snapd. Whoops, let's just do mount. Grep-i for like core 20. And then I should see that, and that's how it's actually getting mounted. So yeah, systemd mounts work just fine, and you can actually set their order too, which is important if you want to make something required for something else before it comes up. Yeah, you needed that for that. Nice. All right. So they don't have anything else in there. But suffice it to say, yeah, you can go. What I do is I would copy this to something else, and then I would make whatever I wanted to mount the way that I wanted to. What and the where. That is kind of an interesting way of writing it, what and where. And then the type would be like, let's say NFS. Maybe I'll add that to our NFS one. Maybe I'll add, instead of doing it via etcfs tab, we'll do it through system mount. I just don't use it much, so I don't. Interesting. All right. So click this, and it says check file system type and mount points, echo the file system. So now we're going to do the same thing, and we're going to look at how our system mounted everything. So we'll mount and look for VDA, and we see that two of those partitions, two of the three partitions are mounted. One is /root and is an ext4 type file system. And then dev15, VDA 15, is boot EFI type VFAT. And then there's a whole bunch of options for it. I say, okay, that's good. I can look at block ID to find that stuff. So for just dev VDA1, I can see dev VDA1 has a label, a UUID, a type, a part UUID, and then it also has just its raw location. So there's 1, 2, so this is 1 is just its location, 2 is its label, 3 is its UUID, and 4 is its part UUID. Those are 4 ways that you can mount it here inside of this system. There are probably other ways, but those are the 4 ways that I know to mount something. So we'll just say that block dev VDA1 into root FS type, so that tells me that it's in ext4. And then if we go look at etcfs tab, there's some information here. And root, we know that root is mounted right here on dev VDA1. That we know that, we see it right there. But in etcfs tab, to mount root, it did this label cloud img-rootfs, and I say, well, what the hell is that? Well, this label, if you look at the block ID for dev VDA1, the label is cloud img rootfs, the label that points to root here. You see how they all point to the same thing? And you might say, well, Scott, where did they determine for Ubuntu, when did they determine to use the label as opposed to the UUID or the part UUID or just the raw name? And I would tell you, I have no idea when that decision was made. I have no idea how they got to that. I will tell you, in Red Hat style systems, you get the UUID most of the time. In fact, I think in my home lab, let's look. So this is a Rocky 9.4, and I say block ID. For my devices that are here, I'm using logical volume management. I see my dev mapper and all that kind of stuff. But how was it mounted? If I cat etcfs tab, it's the UUID for boot, and it's the direct path for the root partition. So there's no rhyme or reason to how they did it. Let's look at my CentOS box. CentOS, which is this guy has root. This is boot by its location, dev xvda. Root is also where the hell's my actual root one at? Well, that's bugging me. Why can't? Oh, here it is. Yeah, this is by its direct device location as well for my root on this box. So sometimes UUID, sometimes direct device location. I'll tell you, Red Hat almost always uses the UUID. But, you know, it's chutes and ladders. Everything points to something else in the system. So this is that. Permission denied for fdisk. Are you sudo? Yeah, you got to be root. By the way, in my environment, here in the lab, one of the funny things about the lab is you are the root user, but your PS1 variable does not look like you're the root user. So I've showed you guys this before. You can set your PS1 if that just bugs you. I could hit equals sign. Geez, H can be pound like that, and then now you would just. Now it would be, you know, because that bugs some people that they're like, I'm not root, and it's like, it doesn't really matter what your PS1 variable says. You're still in the same command line. All right. So we've gotten this stuff done. We've done that. Block ID, root type. We've done all these things. We can look at the disks by label. We can look at them by all of their other pieces. So by path, path is to a certain location. This is in PCI path. You could actually use those if you wanted to. And then we'll echo etcfs tab into root mount info, and then we can move forward. So we checked all those things. Categorian, hopefully this stuff's useful to you. Thanks for the follow. We're just doing lab stuff here, right? Just simple lab stuff. Just walking through the steps. We do labs on Sundays around here, guys. It's just build out labs, work on stuff, understand how these things work. For some of you, you might go, oh, we've done this before. And I say, yeah, but there's value, well, especially for people who have never done any of this, there's value in getting here and looking at these systems. Even if you have done it, there's value in getting in there and looking at systems that you work on day in and day out. Some of you are going to spend your careers on one system. Some of you are going to be kind of like what I've been doing lately, where I have to keep shifting gears for all these different clusters that I'm working on. And if I can't remember everything, because there's a tremendous amount of differences and nuances between my different systems, one of the things I can do is I can go in here and check things quickly, right? Because I know where to go look and I know where to check them. I don't have to remember everything. I have to remember where to go look for it. And then if I can't remember where to go look for it, I need to know how to read the manuals for it. You guys have seen me pull up the manuals at least 3 times today, right? We pull up the manuals, we read things quickly, we figure out how to use the command, and we go. Right? Because sometimes things have to move fast. All right. This one makes you write some stuff and look at the file system space. So clear the screen up. df-h gives you all of the pertinent information about mounted file systems. And in my case, I've got this temp VDA1 mounted to root. It's a 20 gig disk. It's barely used. We have 76% free, and then we've got 15 gigs available of total raw space. So we can go and just throw that data out into a location. If you want to see what that looks like, that command you just did, just hit that and it'll tell you, oh, we just carved this one thing down. So if you want to go take that apart, it's df-h/, which will just give you this one line. Then you, and then you remove this, which is the header line, and then we did an awk, and we printed for the second column, which is right here. So that's how you got that 20 gigs. All right, and then I said let's just make a giant space on there. So df-h/, we'll see that we've got 15 gigs available, and we're just going to make a giant file that's filled with zeros. Called dev0. It's called root big file. That's what it's going to write out to. And it took our system about 3.5 seconds, a little over 3.5 seconds, at 872 megabytes per second to write that 3.1 gigs of all zeros. All it did was go to the kernel and get a 0 off the stack of zeros. There was just a bunch of zeros laying around. And it just wrote them all out to big file. It used a block size of 1024K. That is important when you're writing stuff out to, well, that's important in general, but the block size you choose to use can affect write performance into storage area networks, and you want to try to optimize it to the writes of the block size of the file system. You'll get some performance increases out of it. And then the count in this case is 3000, so it wants 3001 meg files, so that's 3 gigs. All right. If we go and we look, we will now see that we have used 3 gigs more of that space. That's about what we expected. There's more used, less available, and we've got this file that is about 3 gigs in size. There you go. Fail locate command to create. I've never used fallocate. I don't know what that is. I've literally never used this command. That's pretty cool. Yeah. And then I gotta give, I guess, the name of a file, right? It did allocate basically immediately, but we didn't get to see. So one of the things is that's pretty cool, and it did allocate all that space, and that's awesome. But if we wanted to just see how long it took to write, this is a useful thing, and I use this a lot for like hitting remote systems and seeing how fast I can actually send and receive data out of it. But I do like that fallocate. That's interesting. So we'll go look at our system, and whoops, and there it is. There's our root big file, and then it says to write out. Let's write out 10,000 files and see what happens. So we did a df-i now, and we see these things called inodes. And you say, wait a minute, are inodes space or is space space? Well, space is how much actual physical, even if it's virtual, locations that memory can be written to, right? Addressable memory locations. And these are like the little cards, if you want to think of it, like if you remember the old card catalog, where we address to go find where that space is. That's what these are. So df-i will tell me that I've actually just used up 10,000 of these, making these 10,000 fake little quick files that we just made, right? So I get that, you know, for some of you, you've seen this before, and, you know, it's probably like, oh, hey, you know, that's not as interesting because I haven't seen it before. But if you're somebody that's looking at this for the first time, there's a lot of info here about like kind of how the system allocates and how we can go see what's going on with the system. And all of these things that we can check are things that could have gone wrong. I've tell you guys that there's only a couple times in my career have I seen inodes fill up in a file system. Never in a local file system. I've never seen all these get used. But up in a big global parallel file system, GPFS from IBM, I've seen that a few times, yeah. At least two, maybe even a third or fourth. I'd have to think about it, but for sure two, where we weren't out of disk space. You did a df-h, you had all kinds of disk space. But your inodes were gone, and you had no more places to say, go put something out there in that big disk space we had. So thankfully that file system has a way to rebalance, and you can take some from the file system itself and give it to your allocation, and then your system can have more inodes or whatever. It's completely mappable by yourself. But it says, look at you learning Linux. You looked at disk space and usage. So you did all these things, and just pat yourself on the back. That's good work. Some of this, I get it. Some of this is like, you know, we've seen this before. But all this stuff that I'm showing you here feeds into some of this other stuff. So look, we start to go, okay, you've been in the trenches. You've done some stuff. Now, what if we came down here and I told you we needed to benchmark our system now? We're about to add, we're going to bring in a new storage array, and we're going to test it. And we need to know if it actually performs faster in our environment than this other one. The salespeople are going to come in, and they're going to give you raw numbers in a perfect environment. They're going to tell you this you know, whatever, you know, Dodge Charger or whatever can go 160 miles an hour. And there's like 4 asterisks after that they don't say, but it's like on a perfect track with the correct tires, with the, you know, correct type of gas, and unloaded, right? They only have a person or a crash test dummy unit that weighs 120 pounds, right? They're like unloaded. So and with all those things, we've gotten the system to 160 miles an hour before. Well, that's wonderful. How's that shit going to behave for me? How's that going to work for me when I go to run it? I might only be able to get 145 out of it. And he goes, well, Scott, you can't go that fast on the street anyways. And I go, I know. But the analogy falls apart at that point. But in the engineering space, we need to get the same kind of results and test these results. So benchmarking is the way that we do that, right? I've shown you guys my testing methodology before, so we're not going to go over that too much. But benchmarking looks like this. We plan what we're going to do. Then we do some experiments. Then we make the changes or whatever. And then we come back around and we plan again and check. Yeah, Rotom, you weigh more than that. Yeah, I do too. So this is how we do benchmark iteration. We've got our plan phase. We do, you know, what are we wanting to check? We want to check our disks and how fast they write. And when we move to the new disk platform, or when we evaluate the new disk platform, we want to make sure that we're actually getting the speed improvements that we expect. And one of the things, like, okay, so here's examples of things as I've done this that have broken. We find that you will get those speeds if you have control of your network and you can set the maximum transmission unit up. That's almost always a requirement in SANs. We almost always set the MTU from 1500 to some type of jumbo frame. It can be 9,000. I think we can do like 18,000 nowadays. But the point is we can have these big jumbo frames and hold data. And you go, okay, good. Does that work with our workflows? Does that work with the way that we do things? We move a bunch of really small files. Is that can actually give us the efficiencies that we want or no? This is a thing that we might think about, right? So goals and identification, tools and metrics identification. What are we going to use to measure speed? It doesn't make any sense for me to say, well, okay, here I did a DD and I wrote out there, but over here I did that fallocate command. Everybody looking at you would go, your methodology's busted. You used a different thing between the two of them. You have to compare like things, right? This is good engineering. And as much as we can compare like things, we have to apply this other principle. There's a principle that comes from economics that I like for engineering and I use. It's called ceteris paribus. It means all other things being held equal. Because in our big high performance compute space, we have so many things happening. And I shouldn't be doing my benchmarking of my SAN on a system that is simultaneously being LinPack tested for benchmarks. LinPack is the standard testing. Yeah, that's actually spelled right. For like high performance compute systems. If you want to be in the top 500, which is an actual ranking of high performance compute systems, you have to run LinPack jobs against your system. And then you have to give the result. And there's some rules. The LinPacks have to run for at least 30 minutes. They have to be run against... There's a whole bunch of rules for it to actually be considered a real LinPack test. And you can go look that up if you want to get onto the top 500. I have maintained like 7 machines that are in the top 500 in my career. I've shown you guys those, and we can go look at them and that kind of stuff if you care. But my job is always to test and verify that things. This is one of the many things I do often. Test and verify that things are getting the improvements that we expect, or getting, because otherwise we're just sitting there guessing. Like, it feels a little faster than it was. What the hell's that? Back to that, ooh, brother, what is that? That's not engineering. Engineering is engineering, right? We figure out a thing, we measure it, we quantify it, we make some change, and then we verify the improvement. These are things, right? But we need to understand our tools. So it says right here, tools and metrics planning. Then we do planning and resource allocation. We come over, we experiment, we execute our experiment, and then we verify that things are better or worse or whatever. And then if we don't have the correct delta or change, delta is that little triangle symbol, right? People will call it the delta. All they're saying is the change. Did we get, look, we go and we put a new high-speed storage down, and I'm testing it, and it's 6% faster than the other thing. And you say, well, 6% is good. I go, well, we were promised 100%, and it's going to cost 3 times as much. I'm only getting 6%. That's not good, right? So there's this, is it good? Is it not good? Well, that's relative to your expectations and your cost, right? That comes in later. I'm just talking down in the trenches, like, let's do this thing and test our speed of things. So we have benchmark tools like iPerf, where we can test between 2 systems, and I've shown you guys how this works before. We can stress a system and see how it behaves under a certain load. We can do DDs to write and read stuff in and out of file systems. And then here's my practical application. We'd actually make a table like this, and we would go do whatever our tests were and write down our actual speeds that we got, and then we would make a change in some way and gather our new data and say, is it actually faster? Or in this case, we wanted it to be lower numbers. So in this case, they were lower numbers, so that's good. And they are lower numbers in a quantifiable way. 10.5 to 8.5, It's about 20% faster. Not quite, but it's right. So we can go do the math, right? Just throw it on some where's my little, right? Throw your little calculator out there and figure out what the delta is. What's the actual change? And then is it better than we expected? Is it less than what we expected? And it's almost always going to be less than what the salesperson says. But sometimes it's right around what an engineer said or better based on what else is going on in your environment. But now, once we have that, we have like, there's stage gate and there's different methodologies where we look at it and we go, well, we could work a little bit to squeeze it a little faster, follow their recommendations, or we could just say this isn't a tenable solution for us and drop it. We got to make those decisions, but we make those decisions based on data. We don't just guess. Guessing is not, like, I can't tell you how many times in my career I've been on calls and people are just like, well, it feels like this. I'm like, guys, I don't care what it feels like. I understand that there's a slowdown. I understand that we're breaking SLA by not getting the data out as we normally do and should. But just saying it feels like it's probably the database is not the way we want to go about this. And on my side of things, this is one of the reasons I like being Linux engineer so much. Every problem's the same problem to me. You tell me, hey, it's this whatever, it's a database server, and I go, oh, it's a Linux box, all right, and I go do the same Linux stuff to that server. And oh, it's a web server, I go do the same thing to the web server. Like, my checks down in the trenches are the same. Like, is the server utilizing all of its resources? Is it saturated in some way? Are there queues and errors that are caused and being thrown to logs? That's that utilization, saturation, and error methodology. The use methodology that I told you guys earlier. USE. Yep. USE. Is my speech impediment that bad? USE. There we go. Just me over here arguing with my closed captioning system. All right, and then we get into troubleshooting and stuff, right? So those are things systems engineers need to be able to do. All right, so we did our labs. We did our other stuff. We're at about 2 hours. I'll probably hop off of here because I have a bunch of stuff to do today. I have a lot of work stuff to actually do. But my plan, or the plan is this. We've got Discord free. You hang out in Discord. Go do labs. Go do projects. Bolster your resume in whatever way you want. If we go to at the top of Discord, you can always go to events. We have a bunch of events coming up. You guys are welcome to come to any of them or all of them. They're free. They're different, like, guest speakers that I've had, and these are all people who have came and spoke to the group before, and for the most part, everybody has enjoyed listening to them talk about. We've got site reliability. Let's see. Data. This is my brother. This is a data analyst, site reliability engineer, director of engineering, solutions architect with. He's a solutions architect with like 7 certs now in that space. Ben is a professor of economics at a big college in California. Jared is a data architect for Google topics, like data analytics architect. And then Sending Grounds is with the same company that Fisherman is, which is one of the big cloud providers here. So all those guys are coming to talk about different stuff. So if you want to come to any or all of those, you can. I had something else I wanted to show you guys out of here. If you're just looking for resume stuff, there's a bunch of resources here. These are things to go bolster your resume with. Free certifications and free training. So that's all free things to go put on there. I had some other reason I pulled up my Discord and I forgot what I was going to show you guys out of this. Some of you guys like doing the Killer Coda labs. Did you guys know you can do pull requests against the Killer Coda labs and you can help me make those better? So I have a few people that are like my editors. They're like the primary editors. But we get pull requests against that pretty I wouldn't say pretty regularly, but maybe a couple times a month where people will find errors or help out or whatever. And that's just another way to, pump up your numbers. I don't really know much about how people look at GitHub. I'm not a coder. But if you just need to be involved with projects, there's projects in here. Oh, that's what I was going to show you. There's all kinds of projects in here for you to go do that then you can go show on a resume that you know how to do something. right? Isobu, you can do anything you want on Killer Coda. Yeah, you don't need my permission. Killer Coda is a free site. Yeah, you can go in there and make whatever you want. Oh, do you want to add them to the actual Prolog labs? Yeah, I mean, yeah, I don't care. All you got to do is, if you know how to do all that GitHub stuff and you know how to clone it down and make one. And the main things I would tell you is this, right? These are the main things. These are the main gotchas I would tell you. If you were to do one of those in Linux, in my naming scheme, that would probably belong up here in the 01. So anything starting with 0 is our like basic system stuff. And then inside of that, it's pretty I think self-explanatory. Like, what's the index.json? What are each of these different steps? They're all pieces. But this is the thing that'll get you outside of all of this. There's a structure.json. And if you made let's say you made 10 and you said 10 was going to be working in tmux, then you would have to go add it over here in the structure.json so that it would actually get properly shown. But yeah, I'm not that much of a I think that would be the first time somebody added something. Yeah. So anyways, it's something for you to think about if you want to do that. You guys are welcome to, instead of that, you could you don't have to do them under the Prolog labs either. You could always be like anybody else on here and just start your own. There's no rule against that. In fact, I think that looks pretty good, because then you've got labs out there. It's the same thing like Fisherman did. Fisherman doesn't use our lab, right? He uses his own little set of labs, and he's got his own GitHub on it. You could do pull requests against his as well. His stuff's public. I don't remember exactly where his stuff's at, but he's got his 3 junior sysadmin labs, and then he's got running a local LLM, right? So he does his separate completely, which is perfectly fine as well. Just depends how you guys want to do it. I'm going to be writing more labs. I've got at least 2 or 3 more to do before the end of this month, and I have them kind of planned out. I just need to actually sit down and write them, and then I've been updating them and adding them to the book as well, so that we have them as part of the book. So and then the book will get published again in another week or so. So anybody that has it already from LeanPub, it just pushes out a new version to you guys. So that's kind of cool. Or it tells you to go download it, I think. Or it might push it out. I don't know exactly what it does. But you guys get anybody that gets the book from LeanPub gets, you have all the future versions of it as well, which is kind of cool. Kind of a cool little thing they do. Like, they allow you basically to just start working on something even before you get it all done, which I think is kind of a cool little thing. Thanks for that, Robdom. Yeah. And then, yeah, I finished all my Deathgate cycle, which was Margaret Weiss and Tracy Hickman's books from the early 90s. They didn't, it's funny, they didn't hit like they did when I was a kid. When I was a teenager reading them, they were great. As an adult, they were okay. They were fine. They just weren't. I've read a lot since I was a teenager, and they were okay. Like, I get the appeal, but I need to read some of their other stuff and see if that stands up to the test of time. Like the Star of the Guardian series, which was one of my favorites from them. That was pretty good. In fact, that one has been criticized a lot for being similar to Star Wars, although I see a lot of differences, so I don't know, maybe that's me. But is Linux programming frequently used in embedded systems? Verified user 31, yes. I would say Linux programming is probably one of the most, if not the most frequently used type of operating system for not quite down at like your PLC layer. A lot of those are just like straight like C or C++ programs, but no, if you have an OS on something and it's got to be lightweight, a lot of times it's Linux under the hood. Yeah, because we can make our operating systems very small. We can strip a lot of this stuff out that we were doing earlier. Anyways, all right, so here's what I'm gonna do. I'll drop off of here. We'll go find somebody to raid over on the Twitch side. YouTube guys, I appreciate you guys hanging out. Yeah, let's go see if anybody we're following is on. I will go hit up Practical. He's doing fun stuff. And Practical NPC, if you guys don't know him, he builds a game. He does a lot of coding on stream, so some of you guys probably like that stuff. Your Fom said, how often do I stream? I try to stream 3 or 4 times a week, sometimes 4 or 5. It just depends how busy I am. I don't think I'm going to be on for the next 3 days because I am absolutely swamped with work and college teaching and going to college with my doctorate. I am super busy. In fact, I'm super busy for the rest of today. So let's go raid, and I will see some of you guys later on this week. I might pop up. Also, your form, if you ever get stuck or you're like, hey, like, I want to talk to these guys, just go find us down in Discord. We're all down there pretty much all the time. So, all right, take care, everybody.